The customer needed 60 MHz bandwidth record from 10 MHz to 6 GHz bandwidth. As we know, the PXI Express 5663 vector signals analyzer cannot record a signal with 60 MHz bandwidth. That's why we decided to create the following system. For 60 MHz bandwidth RF record, we must use 3 synchronized vector signals analyzers with synchronized external LOs. Each one acquires the IQ data with 20 MHz bandwidth, and after acquisition these neighboring bandwidths via the software concatenated to one 60 MHz bandwidth. For synchronization of these 3 vector signal analyzers, we needed 3 synchronized external LOs. That's why we will get these LO signals from 3 vector signal generators with the same external LO signal which shared between each of one. For a concatenation, we use this one external LO which gives 3 signal to LO input of our 3 vector signal generators with the same sampling rate. Mathematically, we produce 3 different LO signals which are different, have a separation between each one in 20 MHz. So this transformation used in LabVIEW. For demonstration of this concept, we used 2 vector signals analyzers, which configuration we will show in our PXI Express. Here we see the probe signal, which will be used for signal simulation and for acquisition with these 2 analyzers. Here we have LO, our singleton generation for generating LO, which output connected to LO input of one of our vector signal generator, LO output which one's connected to LO input of second vector signal generator. After mathematical computation, we have 2 external LOs which different of signals are 20 MHz. Outputs of these generators connected to input of our 2 vector signal analyzers. Of course, we have connected our synchronization part too. So, from our singleton generation, from our probe signal, we have power division for 2 parts, and these 2 parts connected to our vector signal analyzer inputs. Now let's show and see our system in real work. Here we have the signal for our probe or simulation. Now we start the generation for some sinus on 45 MHz band. Now here we start the acquisition, replace the file, and now we see the accurate data and our singleton on 45 MHz. Here we can see the IQ data of these signals. Here is I, and for the same result for Q, we can put it here. We see 90-degree difference between I and Q parts. And now let's do another thing. Let's generate some simple FM modulated signal from our probe. Let's switch off this one, sinus, and start generate FM modulated signal. Now you see the central frequency on 40 MHz. starting acquisition, replacing the file, and now you see our signal, and here we can see that difference on 1 megahertz as it was set up in our simulated signal. The same thing for our IQ. We see the same signal in I and Q parts.